I am Subjit Roy, welcoming you to mojo4industry development debate on how automation can improve productivity, sponsored by Wake of Automation Private Limited, one of the fastest growing global companies in the field of automation and control technology. And co-sponsored by Ambionics, a leading supplier of special purpose machines, machine controllers, and power supply equipment. Viewers, as you all are aware, deployment of automation within your manufacturing process can help a business in improving their productivity levels, improving efficiency, producing better quality of products, and at the same time, increasing profits. Today, in this episode of mojo4industry development debate, experts from the industry will discuss on the role of automation in improving productivity. They will also talk on how to scale the productivity improvement of automation investment. I'm glad to welcome our distinguished panelists for the day. Today, we are pleased to join by Mr. Jagannath V, Business Head M2 Next Solutions, a BFW subsidiary. Welcome, sir. And joining us today again, Mr. Gajendra Mohan, Business Head, New Business Ventures, Phantom Solutions at Robert Bosch Engineering and Business Solutions. Welcome, Mr. Jha.
Thank you, Suji. Thanks for having me.
Now we invite Mr. Jagannath to start the discussion with his presentation on how automation process can help in improving productivity. Mr. Jagannath worked as an application specialist at a German MNC for 5 years. Since June 2019, he is serving as business head and whole-time director at M2 Next Solutions, a BFW subsidiary. Mr. Jagannath is a senior management professional with 30 years of experience in catering to machine tool builders, auto OEMs, auto auxiliary manufacturers, robot integrators, VMC turnkey, industrial polymer manufacturers, including mobile phones, medical industry, and tool rooms with wire-cut EDMs.
So what is the real meaning of necessity of automation? The first and foremost is to improve the productivity of by maximum utilization of the equipment, so that we know that the OEE of the equipment is at its peak, at its optimal this thing. Next is to improve the performance with improved quality by the consistency of the process, predictable and consistent output, so that you know for sure what would be the output, what you would be able to get from the shop floor when you really automate, so that there is no ambiguity or there are no surprises in terms of deliverables per se from the shop floor. Third is to, as a result of productivity and performance, to achieve better profitability, which means reduce dependency on skilled manpower, minimize cost of poor quality, improved cost per component, and better safety for human and equipment. Now, when we look at automation, what are the typical technologies which really come in handy? Or a 6-axis robot, which most of you will be knowing, and a robot which can work with humans and the equipment as well with full safety, called as collaborative robot, which we also call it as COBO. Then a gantry with 2-axis, 3-axis, and 4-axis, depending upon the type of application and the kind of takt time and loading unloading time. One could use a gantry, including the space constraint and existing layout limitation to modify, so on and so forth. A SCARA robot for high-speed pick and place application, something like 130, 140 picks per minute up to 180 picks per minute. And an AGV to move the material from point A to point B to point C, and also on-demand change in route depending upon the requirement on the shop floor, so that the AGV can autonomously take on a different route based on the demand. And of course, the work envelope can be increased of the robot by putting them on tracks, so that it gives you a better benefit when the takt time is quite high, where a single robot could deliver to many machines, many equipment. Now, typical solutions on the manufacturing, what we can see is a single obo or a robo working with one machine. And when you have a longer cycle time, two machines and one robo working. We are also looking at multiple machines tending where the footprint is really very tight footprint requirement in an automotive, kind of 60 jobs per hour, 80 jobs per hour kind of a requirement, where multiple machines are kept very close and the positioning a robo could be very difficult. Servo gantry would be used, which would really make it possible for loading and unloading from the top, while you have very narrow space and still be able to achieve the cycle time. So typically one machine, different types of machines and a gantry, and an identical type of machines and a gantry would be definitely possible to do. I had automation solutions, what traditionally we have been looking at all these days, which also is quite dramatically picking up. But something to do with what we are going to talk today is about really the digitalization convergence with automation, where there is a lot of intelligence which can be driven from the automation cell, which means that it not only does bring in better productivity, but also gives a lot of information in terms of what exactly is happening in the cell. Now here, what we have done is we have used our data acquisition device, which is used for digitalization on a machine, also in an automation cell, which can not only talk to the machine, but also can communicate the data to the cloud and also gather data from the sensors and the robot and try to effectively give inference from the cell in terms of what exactly is happening in the automation cell, even for a person who is not sitting in the factory. So that's the kind of automation which we are slowly moving towards from the traditional type of automation which I just now spoke. So for example, here, if you see, there was a requirement of having a robot tending to 8 different machines, including automatic gauging, an input conveyor, and 16 variants of components to be machined in that cell, and automatic identification of these components coming into the cell dynamically. And the compensation of each machine, what is being machined and gauged, the compensation had to happen automatically on the tool offset. And then the output from the cell had to go into the pallet transfer, where automatically the forklift would come and lift. So this was the kind of automation where the entire demand from the cell was 0 parts per million, and the data to be available at the tier 1 customer who is sitting 15,000 miles away from this country, and was able to see what kind of SPC, SQC analysis was achieved on the cell. So conceptually, if you see, the tool offset gauging correction happens to the machine through the data acquisition device. Entry and exit into the cell was controlled by a pre-qualified biometric access, which was pre-approved for the people to enter the cell. The robot start and stop can be easily controlled by the data acquisition device. So typical cell architecture is like this. There were 8 machines, 5 VTLs, 2 vertical machining centers, and 1 facing and centering SPM. 3 robots with an input conveyor and an automatic gauging station. And you can see that the entire cell is unmanned, and the whole performance parameter of this cell can be viewed remotely, as long as one has an access to this cell without even going into the factory. This was the primary architecture of the cell. So here you can see this was a PDI trial what we did. It's a brownfield project. There is only one operator who will load the component into the cell. And the cell can handle 14 variants, and there is an incoming part sensor which determines the variant, what kind of variant. So accordingly, the part program on the machines followed by this gets automatically adapted, adjusted. And the part weight is about 35 kgs, and the automatic unloading from the conveyor till the last 40-50 is handled by the robot. So this was a PDI prior to dispatch inspection, which was done on our shop floor, which we have gathered here. So you won't find machines, but you will find the robot activity. So here you can see that there is a flipping of the component then next is, there is a cleaning. We are doing a part cleaning after it is loaded, so that there is no dust before the inspection happens after OP10. So here there is an online inspection which is happening, and the data what is being gathered here goes to the main server of the manufacturer, the customer of OP10 results, and then OP20, which is the fifth machine, is being loaded, while the OP10 activity, whatever is the gauging result, the tool offset compensation is moved to that machine automatically. Again, part cleaning here, which is automatic. Again, gauging. So like this, the entire cell runs automatically. What are the typical benefits? First is the remote commissioning of the automation cell itself. One can do a remote commission without having to go to the site. And remote monitoring of the automation cell, including OEE, plan versus productivity, quality, and maintenance. Up to 73% reduction in skilled manpower. Production parts virtual traceability, tool life management, auto tool offset, auto gauging, auto palletizing. Total safety for humans and equipment due to the biometric access, what was achieved on the cell. Now coming to the very interesting part is the return on investment. If you see the overall investment cost of this cell was something like 1.76 crores. And what we could witness is, we could eliminate almost 80% of the operator on this thing, including their benefit and the cycle time improvement from manual operation to the automatic operation. We could witness from 238 components to 328 components, 320. And if you guess something like 500 rupees per component as the increase in productivity, the return on investment straight away comes in 12 months. So this is the kind of return on investment what one could look at it. Of course, provided the demand on the component should be there for running it in 2 shifts or 3 shifts. And the variants should not change for next 4 or 5 years. That is how, as the value of the component in the supply chain becomes higher and higher, your return on investment will be faster. A lot of buffer application for holding the components like stacker, pallet type, belt conveyor, vibratory feeder, slat type, chain conveyor, different techniques depending on what kind of requirement is there on the shop floor, including the customization and cost performance, HMI and things like that can be handled. So installation conditions, which is favorable for running automation on the shop floor, needs to be met in order to have good, reliability performance. And of course, a gauging station with starting from 100 parts per million to 0 parts per million. One if needs to be achieved, and if you want to look at the statistical performance of the entire process, automatic online inspection is something which is recommended. So in order to have a good solution, you need to primarily focus on gripping systems, gauging systems, conveyor systems, and of course the HMI and the overall architecture. So with this, I come to the end of my session. I just want to give this quote of Albert Einstein, where he said that the true sign of intelligence is not knowledge but imagination. So it's very, very apt and clear for automation, where imagination is something which is really, really going to give us a good part of implementing the automation on a given shop floor, be it manufacturing or be it anywhere. So with that, I would like to end my presentation, and thank you for your attention.
Thank you so much, Mr. Jagannath. It was very well summed up, and explaining us how automation processes can help in improving productivity. At the same time, you spoke about what kind of ROI a person can or an entrepreneur can expect. Now, in this mojo4industry development debate on how automation can improve productivity, sponsored by Backup Automation Private Limited and co-sponsored by Ambionics, let's welcome Mr. Gajendra Mohan. So Mr. Gajendra is currently leading one of the AIoT businesses for Robert Bosch Engineering and Business Solutions. He is enthusiastic about innovation, leadership, and new world order. He will now talk about how to scale the productivity improvement of automation investment. Welcome, Mr. Gajendra.
What I intend to cover when I talk about automation is the role data and technology is playing in making the automation happen, right? There are a lot of manual activities still that is being carried out in the way we are capturing the data and processing the data in order to enhance our productivity. So two basic things, right? One is, if you look at the way the entire supply chain is divided between a supplier to a warehouse to a manufacturing setup where you have multiple machines, you are warehousing, and then finally to your customers through inbound and outbound logistics. What we are lacking today in most of this entire value stream is the way we are using the data or information at different aspects of the value chain and make certain decision in order to improve on the planning aspect, right? So, and how we can leverage that data in order to make an optimal decision. When we do that, there is automatically an automation when it comes to capturing of this data and the decision-making process. So my aim will be to move from the physical and the industrial automation to a realm of process and decision-making automation, which will help improve the productivity. Yeah. There are a few facts which I think most of you working in this domain would be aware of, that currently there is huge amount of production data that is being created on an average by a factory, and more so India is also picking up in having a robust set of data that is being captured at an OT layer, as we call it, as an operational technology layer, and then combining it with the IT layer, which is the information technology layer. However, the fact remains that less than 1% of this data gets acted upon in real time. So while the data sits in the servers, cloud, or on-premise, depending upon how your IT or the data configuration or data lake setup is done, the sad reality is that most of the data is not available on the real time to take decision, which directly improves and impacts the productivity. Yeah. There is another interesting fact that more than a lakh dollars or $100,000 are lost per hour of machine downtime. Hence, if there could be something that could be acted upon in the real time, there will be huge value associated with it, both from efficiency as well as from the revenue side. I wanted to break it down into simpler elements, saying that how is productivity, how are we measuring productivity in our parlance today in industrial manufacturing? Predominantly saying that how is the availability of my individual machine, the performance of the machine, which is nothing but your actual run rate, the planned run rate. In combination, they give me overall equipment utilization, right? Now this process of managing or measuring productivity itself is today not automated. Yeah? Today most of it is being done manually. A digitalization or automation of this entire productivity measurement processes, there is no real-time OEE data available. So if you want to make a decision on a shop floor basis the data that is available, you don't have that information. And until by the time you get that information, it's already delayed. Second, there are a lot of reporting errors that we have found when we started getting deeper into understanding how the data related to machine productivity is captured. Then, of course, there are small stops which really evade the eyes of the operator, and they often go unreported. The barriers that we found related to the adoption. One is, of course, the affordability, where most often there's a high upfront investment, which acts as a deterrence to this automation. Second reason we found was that the standard solutions that exist in terms of automating the entire process of collecting data for productivity improvement doesn't fit into your legacy machines, which is machines which do not have your PLC or any such digitalization. And thirdly, most of the industrial manufacturing setups may have smaller IT departments which cannot evaluate custom solution or build a custom solution on their own. And lastly, most of these implementation want to go via a modular and phased approach rather than going a holistic approach or a one-time approach of connecting all machines using all the data that I showed in the last slide or last conversation. Hence, it has to be a very pragmatic evaluation of how about automating the way productivity itself is measured, right? Because that's the cornerstone of measuring and reporting productivity appropriately. In absence of it, all the business case that we talk about that we want to build in order to push on the productivity side often doesn't hold ground because of the lack of data. And that is what I want to focus on when we talk about automation. That there is a kind of a divergence when it comes to the requirement of different players in the ecosystem, right? The owner, which is predominantly the management or the promoter, has a very different view of what automation and productivity can yield for me. While the supervisor, who is in charge of the shop floor or a cell or a plant, typically has a different parameter or a KPI that he or she is getting measured on. And the other element of operator, yeah, where you are where someone is working on an individual machine, for them parameter is completely different. Yeah. So the first thing is to understand what is the base minimum that each of the stakeholders want when they are talking about automation and productivity. And we realize that there are three basic things that are important. One, how can I make this data measurement or available real time? So there is a value that all three of them understand when it comes to real time measurement of data. Second, can I get additional information in terms of downtime, in terms of benchmarks related to how the other companies, other industries are faring when it comes to OE metrics? And thirdly, if there could be a real-time alert as well along with the data, which can enable someone who is a plant maintenance person or a machine maintenance person or an operator or a supervisor to really act upon it to reduce the number of hours that a machine uses on the downtime side. I think these were the three basic learnings that we had, which is very critical for every stakeholder who wants to get into to managing automation and productivity. And with this in view, we built something called Phantom Solution. I don't want to cover too much detail on the product itself. You can look on to boschphantom.com. It has all the details related to how it connects to machine and gives you the information. The idea, or the basic idea of automating this entire thing around productivity measurement is that we focus more on improving the data to help us improve on the process side, making decisions based on the data to help improve upon the inclusion of industrial automation setup, so that whatever we are deciding today is evidence-based and data-based rather than a gut-free based, right? And that is the intent or endeavor that we wanted to bring in. Additional two USPs that we have been able to build as a part of this machine monitoring itself is, one is that it can connect to all kinds of machine, not only the digitalized machine, but also the machine which otherwise could not be connected. And the second thing is that all the machine could be on one platform where you could see it across any setup. So if you have 7, 8 plants, 10 plants sitting at one place, even while traveling, you can see the status of your individual machine, their availability, performance, and OEE, which helps you make a lot of decision on a real-time basis. Imagine that there are certain orders to be fulfilled. You have certain targets to fulfill. You can take decisions related to increase in the number of shifts, if you have to, number of hours of work, if you have to, if you have an early warning sign in terms of your productivity. Second, having a base benchmark for productivity, we have realized that has helped the organization gain up to 10 to 20% improve in OEE by just monitoring the data.
Thank you so much, Mr. Gajendra, for sharing an enlightening presentation on how to scale the productivity improvement of automation investment, and also highlighting the advantages of connected solutions. Thank you so much. So viewers, at this point of time, automation is no more a buzzword. We all realize that. More or less, we all understand the benefits of automation. Accordingly, automation adoption is on the rise across the industry. However, there are many organizations who have yet to fully realize its benefits. Now we are going to have a discussion on challenges in automation adoption and how to overcome. So to start with, Mr. Gajendra, can you help us to understand the challenges of automation?
There are 2-3 basic areas where we think automation is a challenge, right? One is automation is really built on the layer of process excellence, right? So a lot of organizations, if there are gaps in terms of the way the processes itself is designed, and there is an improvement in the process aspect, may not directly fit in, and they need to maybe towards process excellence and then move towards. Some of the organizations we have also seen leapfrog it and directly move to automation, especially in the greenfield setup. But that is one of the challenges in brownfield setup that we see. Second, I would say is that in the area related to the investments that are made in the automation today. Often there is an understanding of the ROI that needs to come from that automation. Yeah? Automation should also be looked at from a future business building perspective, or a future manufacturing plant perspective. And third, I think somewhere is also our understanding or limited exposure to what automation can for the businesses and the limited application of the same. So I think these are the three reasons, Shubhajit, according to me, based on and understanding in the industry today are becoming the major challenges.
Okay. Mr. Jagannath, do you completely agree with what Mr. Gajendra was talking about?
See, primarily what we have been experiencing on the ground is that, first of all, the customer needs to have this confidence that the demand is going to stay there for at least 3 to 4 years. Okay, this is the primary requirement, number one. Number two, with the disruption coming, around, there is a lot of apprehension in terms of how long an automation part of the cell which is envisaged is going to last is another question, which, there is a lot of apprehension in this area. Number three is reskilling or upskilling of the team within the organization is something very important. There is a fear that whether they will be able to embrace, this is another thing. So how simple or easy it is. So there are a lot of things which are around this subject, depending upon the kind of MSME we are talking about, the kind of tier 1, tier 2. So these are some of the typical challenges which we need to break the ice and then start taking. But then there are a lot of things which are happening at the same time. If we see in the last 6 months, 8 months, the traction in automation has been phenomenal, something like 2x, 3x kind of a demand. So it's coming up, and India is one place where when the beginning has to happen, it will take some time, but once it happens, the growth is going to be exponential. The demand is going to be very high. I think we are in the crossroads. I think we need to little bit wait and then look at how do we, go there. So it's going to happen.
Thank you so much. So thank you, Mr. Jagannath and Mr. Mr. Gajendra Mohan, for your participation and sharing your expert opinion.
Please don't forget to subscribe our YouTube channel and press the bell icon.